So we look at the exercise 11.2. Write the following row of Pascal triangle using combination notation. Okay. So Pascal triangle, we have the 1, 1, 1, 1, 2, 1, and then the 1, 3, 3, 1, and then 1, 4, 6, 4, 1, and 1, 5, 10, 10, 5, 1. Okay, this is Pascal triangle. So for row number 3 is actually this. Okay, so for row number 3, okay, the answer is 1, 3, 3, 1. But they want us to write as a combination notation. So the combination notation, we know that this is the NC0, NC1, NC2, NC3, NC4, something like that. So the N is 3. So for this one, N equal to 3. So the first one is 3C0, 3C1, 3C2, and the 3C3. Okay, in the calculator, we have the 3C0 is 1, and then 3C1 is 3, and then the 3C2 is 3, and 3C3 is 1 also. So this 1331 is actually 3C0, 3C1, 3C2, and 3C3. And B for row number 4, okay, will be this one. This is the row number 4. So for row number 4, it should be 14641. So we have the 4C0, 4C1, 4C2, 4C3, and the 4C4. So we can use the table in the calculator. So we have the 4CX, and then the X start from 0 and at 4, step size is 1. So we have the 14641. Yes, it is correct. Okay. So for the C, okay, row 5. So we have the N equal to 5. Then it will be 5C0, 5C1, 5C2, 5C3, 5C4, and the 5C5. So this one, we have the 5CX start from 0 and at 5, step size is 1. So we have the 1, 5, 5, 10, 10, 5, 5, 10, 5, 1. Yes. So number 2, we use the binomial theorem to find the expansion of 1 plus x to the power of 4. Okay, so this one, if we don't use the binomial theorem, okay, we can use the Pascal triangle, will be easier. So we have the 1, 1, 1, 1, 1, 2, 1, 1, 3, 3, 1, and the 1, 4, 6, 4, 1. Okay, so if we use the Pascal triangle, then it will be 1, 4, 6, 4, 1. Then we have the 1 power 4, 1 power 3, 1 power 2, 1 power 1, and then don't have 1 here. X power 4, x power 3, x power 2, x power 2, and then x power 1. Then we don't have the x here. So it will be 1 plus 4x plus 6x squared plus 4x power 3 plus x power 4. Okay. Binomial theorem. So binomial theorem is actually, we have the a plus b. Okay, so for the binomial theorem is a plus b to the power n will be the NCR. Okay, a to the power n minus r, b to the power of r. Okay, so this one we have the 1 plus x power 4 will be 4C0, 1 power 4, x power 0, 4C1, 1 power 3, x power 1, 4C2, 1 power 2, x power 2, and then 4C3, 1 power 1, x power 3, and then the 4C4, 1 power 0, x power 4. Okay, so this one will equal to 4c0 is 1, then this will become 1. 1 power 4 is 1, x power 0 also 1. Then we have the 4c1. Okay, so we have the 4c1 is 4. So we have the 4x. And then 4c2 is 10, 6, 6x squared. Then 4c3 also 4x cubed. And then x power 4. So these two are the same. Okay, but the question asks us to use the binomial theorem. Then we will use the binomial theorem. Okay, so for this one, we can also write it this way. We have the 4c0, 4c1, 4c2, 4c3, and the 4c4. Then we have the x power 4, x power 3, x power 2, x power 1. Then we have the, don't have x here, x power 0. Okay. Then we have the y power 4, y power 3, y power 2, y power 1, y power 0. So this will be the answer. So it's x power 4 plus 4x power 3y plus 6x squared y squared plus 4xy cubed plus y power 4. So this will be the answer. So for E, okay, before I go to the E, before I go to E, the 4C3, 4C2, and 4C1 is the same here. So for this one, we can have the 4C0, okay, so we have the half x power 4, negative 3x power 0, 4c1, half x power 3, negative 3 power 1, 4c2, half x power 2, negative 3 power 2, and then 4c3, half x power 1, negative 3 power 3, and then 4c4, half x power 4 power 0, and then negative 3 power 4. So we have the 4c0, 1, 2, 3, 4. Okay, half power 4, 3, 2, 1, 0. Negative 3 power 4, 3, 2, 1, 0. So this one will be x power 4 over 16 minus, okay, 3 times 4 is 12. This is 4. 4 divided by 2 is 2. 2. So minus 6x cubed. And then this one plus 6 divided by 2 is 3. So 3 times 9, 27 x squared. And then minus 4 times 27. 4 times 27 is 108 x. No, okay. So 4 divided by 2. Okay, 54 x, and then plus 81. Okay, so what we have here is 4c0 multiplied with the half power 4, and then multiply with the negative 3 power 0. So the first one is 1 over 16. Okay, this one is 1. Then this is 4 minus 1. And then this one is 0 plus 1, 1 here. So wait, 1 over 2 power 3. Okay, so I did a mistake here. So this should be negative 3 over 2. Okay, just now I just cancel the 4 with 2 here. But this one is 4 cube, 2's cube. Okay, so this one also I make a mistake. We have the 6 divided by, so we have the over here, 2 here. Okay, so we have the 4c2 half, and then 4 minus 2, and then we have the 0 plus 2, so it will become 27 over 2. And then we have the 4c3, and then 4 minus 3, and then this one is power 3, negative 54. And then we have the 4c4, so this one is 4 minus 4 or 0 lah. Okay, then this will be the power 4, 81. Yes, correct. Okay, so for this question, power 5. So if we use the Pascal triangle, we have the 1, 1, 1, 1, 1, 2, 1, 1, 3, 3, 1, 1, 4, 6, 4, 1, and 1, 5, 10, 10, 5, 1. So if we use the Pascal triangle, 1 minus x to the power of 5 will be 1, 5, 10, 10, 5, 1. So 1 power 5, 1 power 4, 1 power 3, 1 power 2, 1 power 1, 1 power 0. Negative x power 5, negative x power 4, negative x power 3, negative x power 2, and negative x power 1. So negative x power 0. Okay, so what will we have will be 1 minus 5x plus 10x squared minus 10x cubed minus plus 5x power 4 minus x power 5. Okay, so if we use the binomial theorem, then it will be 5c0, 5c1, 5c2, 5c3, 5c4, 5c5, 0, 1, 2, 3, 4, 5. And then we have the 1 power 5, 1 power 4, 1 power 3, 1 power 2, 1 power 1, 1 power 0, negative x power 5, negative x power 4, negative x power 3, negative x power 2. So this is negative x. And then negative x power 1, the negative x power 0. Okay, so we have the 5c0 multiply with the negative 1 power 0. Okay, then this is 1. Okay, so this will become 1 plus the 5c1 negative 1 to the power of 1. Okay, the 1 power 5, 1 power 4 is always 1. 1 power 2, any value will be 1. Okay, so it's negative 5. So it's negative 5x, and then we have the 5c2 negative 1 power 2, and it is 10. So plus 10x squared. And then we have the 5c3 negative 1 to the power of 3 is minus 10x power 3. And then we have the 5c4 negative 1 to the power of 4, then it's 5 plus 5x power 4, and then minus x power 5. So 5c1 is actually 5, negative 1 to the power of 5 will be negative 1. So that is this one. So for this kind of question, if we have a 1 negative here, then it's the result that will come out will be plus minus plus minus plus minus. So the sign is will be alternate, positive negative positive negative positive negative. Okay, so if your answer is not positive negative positive negative positive negative, then that means somewhere wrong already. Okay, okay, so for this one, 2 minus x power 5, phi C0, phi C1, phi C2, phi C3, phi C4, phi C5. Then 2 to the power of 5, 2 power 4, 2 power 3, 2 power 2, 2 power 1, 2 power 0, negative x power 5, negative x power 4, negative x power 3, negative x power 2, and then negative x power 1, and the negative x power 0. Okay, then we have phi C0. So we have the phi Cx multiply with 2 power phi minus x multiply with negative 1 power x. Okay, so we have a 0, 0, 5 minus 0, 0, and then the x is 0. So CLC, I have a 0 here, then we have a 32. So we have 32. So this is how I get it. Okay, and then uh, we have 1 here, then it's negative 80. Negative 80x, and then we have the 2 here, 2, then we will have 80, and then we have the 3 here, that is negative 40, and then we have the 4 here, is 10, and we have the 5 here, it is negative 1. Okay, so plus 80, okay, x squared minus 40x cubed plus 10x power 4 minus x power plus minus plus minus plus minus. So actually we have a faster way. So the faster way is actually, since I can write this equation, so I can form a table phi cx multiply with the 2 to the power of 5 minus 2 to the power of 5 minus x, and then multiply with the negative 1 to the power of x. Start from 0 and 5 subside 1. So we have the 32, negative 80, 80, negative 40, and then we have the 10 and negative 1. Yes. Okay, so we have the J, this one. So phi C0, phi C1, phi C2, phi C3, phi C4, phi C5. Then 1 to the power of 5, 1 to the power of 4, 1 to the power of 3, 1 to the power of 2, 1 to the power of 1, 1 to the power of 0, negative x over 10 to the power of 5, negative x over 10 to the power of 4, negative x over 10 power 3, negative x over 10 power 2, negative x over 10 power 1, and negative x over 10 power 0. Okay, so we have the phi cx 1 to the power of 5 minus x, and then negative 1 over 10 to the power of x. So we have negative half, 1 over 10, negative 100. Okay, and then these two will, okay, so this is actually half. This is actually 1 over 10 negative half. So we have the 1 minus half x plus 1 over 10 x squared minus 1 over 100 x cubed, and then plus 1 over 2000 x power 4 minus 1 over 10,000, no, 100,000 x power 5. Yeah, 100,000.